Have a pleasant day, sir. You shine truly this Christmas and a prosperous new year. We are the Group 8. We are very thrilled to propose through an insightful exploration of our design project, a 120 megawatts hybrid diesel and solar power plant in Bohol, innovating for a sustainable future. So this project is an exciting development in the renewable energy sector. This project aims to combine the reliability of diesel power with the sustainability of solar energy to provide a stable and eco-friendly power supply to the province of Bohol.
So for the problem, Bohol, known for its vibrant tourism, agriculture, and growing industries, faces an increasing demand for reliable and sustainable energy to support its economic expansion. As the island continues to thrive, ensuring a stable electricity supply has become a critical priority. So for the proposed solution, to address this 120 megawatt hybrid power plant that integrates diesel generators, solar power, and battery energy storage system or BESS is proposed. This system aims to provide a dependable energy source while promoting environmental sustainability and reducing dependence of fossil fuels. The plant's design reflects Bohol's commitment to eco-friendly development, aligning with its vision to balance the progress and environmental conservation. So, for proposed solution, uh, the focus is on this is to make a power, more electricity power in friendly environment ways. So for the power plant design and energy analysis, as you can see here, meeting the load, uh, starting from meeting the load curve in 2023, starting from January, it increased to May up to October. So the average load in the graph, basing on the graph, is 94 megawatts, and the peak load is 113 megawatts. For the plant capacity, the capacity of proposed 120 megawatt hybrid diesel and solar power plant in Bohol covered in this section. It is intended to match the province's load curve, which has an average load of 94 megawatts and peak demand of 113 megawatts, with a contribution of 100 megawatts or 83.33% of the total capacity. The designed power plant offers a dependable energy source for both base and peak demands. By supplying 20 megawatts or 16.67 of solar power plant lowers the carbon footprint of the system while minimizing the consumption of diesel fuel and operating expenses during sunny hours. So for the plant configuration, that's diesel power plant 120 megawatt diesel engine man 32 by 44 CR. Okay, as you can see in the picture, no? And diesel power plant 100 megawatts alternators SGN 100A to 200 OA series, and diesel power plant 100 megawatts cooling system back VV series, and diesel power plant at 100 megawatts exhaust system Uranax Care SCR systems. Diesel power plant control system maps Mitsubishi automation platform system. Power plant configuration sa solar panel. Switch is capacity is 20 megawatts. So for the solar farm, 20 megawatts, GLV5 inverter, and the storage, Siemens storage.
And for the land area, it required of 50 hectares for the panel arrays, access roads and maintenance area, and it has a perimeter of 5,472.51 meters, and the land area is 159.41 hectares. And the area is located at Barangay CABAHUG, Bohol. And again, the land area is 159.41 hectares. So in order to distribute the generated power of our power plant, we will use electrical substation and grid integration in order to safely and efficiently distribute the generated power of our power plant into our consumers. In order to do that safely and efficiently, we will use control center. So we can see, as we can see in the picture, no, they have the parts, the inverters, the fuel tank, the fuel pump, the diesel generator of our substation. So we will need the control center in order to efficiently and safely distribute the the power generated from the power plant onto the consumers.
So in an energy analysis of a power plant, so here is the diesel cycle. So we could see the schematic diagram of a diesel cycle power plant and the diagram of a diesel cycle, the PV and TS diagram. So sa TS diagram is na ay ang 2 to 3 is heat added and 4 to 1 is the heat rejected. So in the diagram we could see that 3 and 4 is isentropic, wherein S3 is equals to S4 and S1 is equals to S2. Then the specification of the MAN 3244CR diesel engine. So mao ni ang specification of diesel engine nga gamiton. Here is we could see the number of generating units. So to get the to know the generating units, we use the formula of generating units is equals to proposed power output over rated power output of the genset per unit. So 100,000 kilowatts over 10,000 kilowatts, so mo kuan siya og 10 units. Then the mass of air, so P1 V1 is equals to MRT1. Muna to formula gamiton and then makakuha na to ang mass of air. Next is the heat added. So nakita na, we could see that in the TS diagram that the heat added is 0.2 to 3. So get the value of enthalpy in the steam table and we could get the heat added and also the heat rejected. Then work net is heat added minus heat rejected. And next is the thermal efficiency of the power plant and the diesel cycle. So thermal efficiency, work net over heat added, then mass of the fuel. So work net over mass of the fuel times the heating value. So the calorific value of heavy fuel is 42,700 kilojoules per kilogram. Next is the indicated power. So IMAP is equals to work net over volumetric displacement. So to get the indicated power, first is we get the IMAP, then substitute, and next is the brake power. So hence we have the IMAP, so we could get the brake power. Next is the friction power. So friction power is indicated power minus the brake power. And the mechanical and generator efficiency. So it is very important to get this so that we could know how efficient our power plant is. So next is the solar energy analysis. So solar energy analysis is the number of modules and electric power. So number of modules is equals to proposed power plant power output over rated power output of the panel per module. We have 20 million watts over 600 watts per module. So we get that 34,000 modules. Then actual power output, we have 20.4 megawatts. Then the solar farm output is 67.014 megawatts hour per annum. Then we're gonna put the battery storage system energy analysis. Number of units, we have 17 units. Then storage capacity of the battery bank, 17 units times 1,200 kilowatts per unit is equals to 20.4 megawatts muna tong storage capacity.
So for the project location, area, and building, and the location map highlights the hybrid power plant site in Cabahug, Bohol, emphasizing its accessibility, proximity to grid infrastructure, and integration of diesel power plant and solar farm facilities. It has a perimeter of 5,472.52 meters and a land area of 159.41 hectares, as you can see in the picture, no? And it is stated the area is located at the Barangay Cabahug, Bohol, since it has a vast of flat and barren land, which is suitable for this kind of power plant, especially for the solar farms, since it requires a lot of land area for the solar panel arrays in order to generate electricity. So for the power plant building, so the power plant comprises two buildings, each housing 8 diesel engines with only 10 engines in operation, and the remaining 6 as reserves. The buildings are designed for efficiency, safety, and seamless integration with the solar power farm. So as you can see in the picture, we base the power plant building for the newest Dilimara diesel power plant located in Malta, since this building houses 8 diesel engines, and since we only need 10, and we will need to use 2 of these buildings in order to have 10 engines and in 10 engines in operation, and we have the remaining 6 as reserves. So for the plant layout, the layout integrates the diesel power plant buildings with a solar power farm, optimizing energy production and site utilization. It includes areas for the BASS, or the battery energy storage systems, transformers, and auxiliary systems, while ensuring safety and operational efficiency. So as you can see in the picture, where it shows the plant layout of our diesel and solar power plant, as we can see, we have the 2 diesel power plants in the left part, diesel power plant buildings in the left part, which is highlighted in the upper left part, and next is the battery energy storage system, which is located in the lower of each solar panel arrays, and in the upper right part you can see the highlighted part, or the highlighted area of the solar panels scattered and distributed all around the area.
Good day, sir. I am CELENE GINGO, and I will be discussing the power plant economics. So for the first element, we have the fixed element, and the expenses included in this are the capital cost of the power plant, cost of primary transmission line, corporate tax, and assumed interest rate, which has a total of 2,372,644,216 pesos. And for the annual insurance fees, the total is 1,208,196, and the salvage value is 208,864,895 pesos and 303,727.65 pesos. And the general maintenance cost is 2,500,000. And for the overall fixed element expenses, the total would be 2,585,521,035. For the next element, we have the energy element. So the expenses would be diesel fuel, which has a unit cost of 66 pesos, and the quantity is 100,000 liters per year, and the total would be 6,615,000. For the cost of water, we have 786,000. By the way, the data for the fuel is from CEIC, and the data for the cost of water is from BWUI. And next is the cost of labor, which has a total of 36,346,224, and the oil, waste, and supplies has a total of 4 million. And for the overall energy element, the total would be 43,747,224. The profit element is assumed to be 10% of the capital cost, so the profit element is 208,864,895.2 pesos. Next, we calculated the cost of energy per kilowatt hour. So we have the total annual cost of energy, which is 2,838,133,154. And the energy rate is calculated by the ratio total annual cost of energy over the area under the curve times 365 days times zero point 0.8. So the area under the curve is 2,077,000 kilowatt hour per day. So the energy rate is equal to 4 pesos and 68 centavos per kilowatt hour. As for the plant capacity factor of both power plants, we have the plant capacity factor of diesel, which is equal to 0.94, and the plant capacity factor of solar is 4.7. And then we calculated the daily energy demand for both power plants, and the total is 1,974,000 kilowatt hour per day. And for the daily income, it is just the product of the daily energy demand times the energy rate, which is equal to 9,238,320. Lastly, we have the annual income, which is equal to daily income times 365 days per year and is equal to 3,371,986,800 pesos. And the return of investment is equal to the ratio of the total annual cost of energy over the annual income, which is equal to 0.84, or if we round it up, it is equal to 1 year. For the last part of our presentation, I am going to discuss the environmental, health and safety, social and ethical concerns regarding hybrid diesel and solar power plants. First, we have the environmental concerns. Hybrid solar and diesel power plants impact the environment in several ways. Solar components require mining for raw materials, while diesel has issues regarding its waste, like the greenhouse gases and pollutants such as oil slugs. So it is important for the power plant to have proper waste management to address these issues. Next, we have the health and safety concerns. We all know that diesel power plants emit greenhouse gases, and this could affect human health, which can cause respiratory issues and other illnesses. And aside from that, we also have noise pollution. So it is very important for the power plant and its workers to follow safety protocols and protective equipment. And lastly, we have social and ethical concerns. One of the concerns usually is regarding environmental health and safety concerns, and also the labor standard. So it is important for the power plant to follow ethical labor standards, as well as preserve the community's environment to avoid issues such as concerns about sustainability and resource equity.